warming. However, the emission cuts you can see here in blue and in gray, they're inefficient to reach really a net CO2 balance, which is needed to reach these warming targets. So we require some active removal of carbon dioxide from the atmosphere. However, on top of that, as it's really challenging to cut emissions and also to scale CDRs, current policies are not on track to reach these targets, and reaching a 1.5 warming scenario is nearly impossible to achieve anymore, and current policies really have to step up in order to reduce emissions further and scale up CDR. Just to put everybody on the same picture, so you don't only have to remove CO2 from the atmosphere to qualify CDR, but it should also store it durably. So it has to be stored for centuries and longer with minimum leakages in order to have an impact on the climate. Today, carbon dioxide removal is mostly planting and tending trees. You can see out of the 2 gigatons of carbon dioxide removed from the atmosphere on an annual basis today, 99.9% is based on trees, and only 0.1% is on novel CDRs, with hardly any contribution of enhanced weathering. Trees, everybody likes trees. I like trees. To give you just a personal example why trees are maybe not the solution. So here's a mangrove example from a mangrove restoration project my father-in-law is conducting in Paramaribo in Suriname. It's next to French Guiana, and he had been planting mangroves for more than a decade, and he had famous and less famous people planting mangroves with him. And these mangroves have this year or last year, within a few months, 50 hectares of mangrove forest has died off within a few months, because most likely because of the combined effect of triple La Nina and the dredging of the Paramaribo Suriname River, because they want to welcome the big oil tankers in order to exploit the oil fields in the coastline. So all these efforts they want to do within a few months. But that's not, it's just one of example out of many sustainability issues with planting forests on a massive scale. For example, if you convert savannas into a forest, you lose biodiversity. It competes for land for food production, so it has different threats. And recently, the PS et al. Estimated the amount of carbon dioxide removal achievable with low risk based on kind of tree-based CDRs, and they only amount to a few gigatons unless you really want to accept larger risks to other sustainability goals. So the big challenge is how to scale CDR on the levels required to limit man-made climate change. One of the measures in the portfolio of CDRs is enhanced weathering. It's a very promising, very nice one. I don't have to advertise it to this group, so I just want to briefly list the main principle. The main principle is based on a natural reaction of silicate rocks with CO2. The rate, this reaction is very slow. It's a very small rate compared to the human perturbation of the carbon cycle. And this rate is limited by the exposure of these minerals, temperature, water, and CO2. It's believed to be a thermostat of the Earth, balancing the climate and really geological timescales. And in order to speed this process up to levels required to make a contribution or fighting the man-made perturbation of the global carbon cycle, you need to scale these rates up by orders of magnitude, and that you can do by mining, grinding, and spreading basalt rocks. That's the basic principle. However, getting this basic principle into reality, it's not just about mining, grinding, and spreading, but you also need to have the acceptance in societies, and we see already with some previous studies that the social acceptance of such technologies can be quite different. For example, compared in Europe, it's rather low, while in Southern Hemisphere countries, that people are more accepting such technologies. You need a robust regulation and financing in order for companies to prosper. And also you need reliable and accurate monitoring and reporting of this CO2 removal. Otherwise, it's just a business without the impact on the climate. Here in our lab, we are very interested in the side effects, and I think the side effects are also key in these technologies. It's not about just removing CO2, but there's a couple of side effects of enhanced weathering, which are important. So if you add rock dust to the soil, you affect the physical soil environment by adding there some particles, but also the biological agents like plants, microbes, and microorganisms, they are affected by the addition. And in return, biota in particular is affecting the weathering rates itself. So you have a two-way coupling of the environment living in dead and the rocks you add there. It's very important because once you add the rock, it will be very hard to remove it. It's impossible to remove it again. So it really changes the ecosystems. The side effects, they have some positive aspects with respect to scaling enhanced weathering, but also negative ones. For example, having a positive effect on plant health and soil fertility is an incentive for farmers to use it as a soil conditioner. It provides organic carbon sequestration, which can be an additional source of income or drawdown of CO2. It can have positive or negative environment impacts. And overall, it's a challenge for the monitoring, reporting, and verification because we have changes in organic and inorganic carbon reservoirs in the soil, plants, rivers, and ocean. So this is quite a challenge. To give you a bit more of an example of what we have been doing at the LSE, we have been looking at the one side effect, which is the release of phosphorus from basalt rocks. And we have looked to what extent this stimulates plant growth in natural ecosystems, which often are limited by the availability of phosphorus. And we found here on the map, you can see in an idealized simulation where we just spread natural systems with basalt in a computer model, that depending here on the color scheme from the more greenish and yellowish points, the overall CDR is dominated by the plant growth and carbon storage response. So this seems to be a non-negligible carbon dioxide removal pathway. However, we do not advocate to spray natural ecosystems. It's just to illustrate that the side effects should be considered the positive ones. On the other hand, we know there's large amounts of organic carbon in the soil. So there's more organic carbon in the soil than the combined reservoir of plants, atmosphere, and organic carbon in the ocean. We recently estimated together with researchers in China that the soil inorganic carbon content is in a similar order of magnitude than an organic one, and it can be quite dynamic too. So we have a huge amount of carbon, organic and inorganic, already present in the soil. And if enhanced weathering triggers a release from this large reservoir, it would make all the efforts with the carbon drawdown cancel, and this carbon in the soil has accumulated over thousands of years. So this could be a potentially large threat, although it's not clear to what extent such losses can be triggered. So to summarize it up, we think that the side effects really can affect all the different parts important for the scaling of enhanced weathering. The idea for this specific workshop to discuss enhanced weathering in Europe was a paper from the UK group around Bierling et al. They showed the different CDR potentials for different countries worldwide and in Europe based on an assessment of the technological and economic infrastructure and problem area, etc. And they estimated, for example, that for France, a large fraction, up to 40% of the nationally determined contribution to the Paris Agreement could be realized by enhanced weathering alone. This is much different in other countries, like in Germany. It can be only a very low amount, and this is mostly related to the source of energy these countries use. France usually uses, still relies for the year 2030, for which this study was done, on nuclear power largely, while Germany still burns a lot of gas in these scenarios. So the question is why there's this difference between these countries, and also if you look at the research and the economic players acting in the two countries, it's the opposite. We have more of that research and economic activities being done in Germany compared to France, which could be related to the love of French for the 4 per million initiative, or for the need of Germans or Germany to compensate for the CO2 emitted by keep burning gas. So this is the overall topic or question to keep in mind for this workshop. So we invited different young researchers and economic actors from Europe to discuss what are the barriers and opportunities for enhanced riding in Europe. And we organized it around these 4 topics or themes, which are the implementation, the scaling and public perception, side effects, and MRV. And the day 1, followed by the introductory course, we have a session on implementation, followed after the coffee break by the session on scaling and perception. And tomorrow we have a half day on side effects on MRV. So with this, thank you for attention.